Welcome to Learn Chemistry Together. This video is about the rise, fall, and legacy of CFCs, a lesson in global environmental action. We are going to talk about a class of chemicals known as chlorofluorocarbons or CFCs. To understand their story, we have to travel back to the 1920s. Back then, refrigerators and air conditioning units used dangerous, toxic, and flammable gases like ammonia, methyl chloride, and sulfur dioxide. Leaks from these systems often led to fatal industrial accidents and household tragedies. Enter CFCs. First developed in the late 1920s under trade names like Freon, they were hailed as a miraculous breakthrough. They were synthetic organic compounds composed of carbon, chlorine, and fluorine. Crucially, they were non-toxic, non-flammable, and chemically stable. They quickly transformed modern life, finding widespread use not just in refrigeration and air conditioning, but also as aerosol propellants in hairsprays and deodorants, as foam-blowing agents for insulation, and as solvents for cleaning delicate electronics. For decades, humanity felt entirely safe using them. The unseen threat: ozone depletion. However, the very property that made CFCs so safe on the ground, their chemical stability, turned out to be their fatal flaw in the atmosphere. When CFCs were released, they drifted slowly upward, escaping the troposphere and entering the stratosphere. There, high-energy ultraviolet, UV, radiation broke them apart, stripping away free chlorine atoms. This triggered a devastating chemical chain reaction. A single chlorine atom can catalytically destroy over 100,000 ozone molecules before finally being neutralized or removed. This massive destruction began thinning the stratospheric ozone layer, most dramatically over Antarctica, creating what the world came to know as the ozone hole. Why did this matter? The stratospheric ozone layer acts as Earth's natural sunglasses, shielding us from harmful UVB radiation. Its depletion triggered a global surge in risks for skin cancer, cataracts, and widespread damage to marine life such as phytoplankton and terrestrial ecosystems. Regulation and the global response. Faced with an unprecedented global environmental crisis, the international community did something remarkable. It united. In 1987, world leaders signed the Montreal Protocol, a landmark international treaty designed to phase out the production and consumption of ozone-depleting substances like CFCs. It remains one of the most successful environmental treaties in history, eventually achieving universal ratification by every member of the United Nations. Of course, phasing out CFCs required substitutes. Initial replacements: industries turned to hydrochlorofluorocarbons, HCFCs. While less damaging to the ozone layer, they proved to be potent greenhouse gases. Later replacements: technology advanced to hydrofluorocarbons, HFCs, and natural refrigerants. While HFCs saved the ozone layer, many turned out to be powerful drivers of climate change, leading to further updates like the Kigali Amendment to phase those down as well. The story of CFCs is a powerful paradox. It is a cautionary tale about how human innovation can unintentionally disrupt planetary life support systems without us even realizing it. Yet it is also a story of hope. It proves that when science diagnoses a global threat, humanity can listen, cooperate across borders, and take decisive action to heal the planet. The healing of the ozone layer today stands as proof that environmental policies can work, a blueprint we desperately need as we tackle modern global challenges today. Thank you for watching. Click subscribe for more.